Hi guys, today we're going to talk about translating between tables and expressions. And as we had mentioned in class, we are going to be looking at patterns. And if you can find a pattern, you can write an expression for it. So let's start with a quick review, just evaluating expressions. So looking at this table here, you have H, which represents all the values that you can plug in for H in the expression 3H minus 2. Remember, 3H means 3 times H minus 2, and using the order of operations, we'd have to multiply first and then subtract. So if I wanted to find the values for when H is 6, 7, 8, 9, or 10, I simply substitute. So, for example, if I wanted to find the value of this expression when H is 6, I would simply do 3 times 6, which is 18, minus 2, and get 16. Same thing with 7. If I wanted to find the value of 3H minus 2 when H is 7, I would take 3 times 7 and then subtract 2. 3 times 7 is 21, minus 2 is 19. When I plug in H, or 8 for H, 3 times 8 is 24, minus 2 is 22. When you substitute 9, 3 times 9 is 27, minus 2 is 25. And when you substitute 10, 3 times 10 is 30, minus 2 is 28. And you can substitute any value into an algebraic expression. And as we had talked about before, sometimes that value is going to be given to you, and sometimes you have to come up with the value based on the situation and the problem that you're trying to solve. So in this example, 3H minus 2 is the function, or the algebraic expression, that relates the left column with the H, with all the H values to the right column. And so in order to get from the left column to the right column, you had to plug in or substitute the value. So in this video, we're actually going to work it backwards. What if you have the values and you come up with the algebraic expression? So looking at this function that relates, we're looking at this table, we need to determine the function that relates the left column to the right column. So the first thing we need to do is look at the patterns. You notice that each time I look at a number in the left column, to get to the number in the right column, I have to multiply by 4. 1 times 4 is 4. 2 times 4 is 8. 3 times 4 is 12. 4 times 4 is 16. 5 times 4 is 20. Another way to look at this, if you've got all of these values in a row, you can look and see each time I go down one row, I'm adding 4. So I'm repeatedly adding 4 to each row. And we know that repeated addition is really multiplication. So we assign a variable for the left column. In this case, I chose n. And then I have to create an algebraic expression for the right column that tells me what I need to do with n to get to the right column. And as we looked at before, we need to multiply it by 4. So 4n would be the algebraic expression for this table, or for the pattern in that table. So let's look at this one. Looking at the right column, knowing that I'm going 1, 2, 3, 4, 5 all the way down, I'll notice that every time I go down or add 1 to P, I'm also adding 1 to the right column. So if I'm repeatedly adding 1, that tells me that I'm going to multiply P by 1. And so 1 would then become the coefficient of P. But just multiplying it by 1 doesn't get me this number in the right column. So I need to ask myself, after I multiply P by 1, then what do I need to do to get this number in the right column? And you'll notice that you're taking every number in the left column and adding 3 to it. So my algebraic expression is I'm going to take whatever value is in P in the P column and add 3 to it. So P plus 3. And notice, what's the coefficient of P if there's no value in front of it? And that's 1, because I'm adding 1 repeatedly. All right, let's look at this one. In column W, what do I need to do to each of these values to get the value on the right column? So I'm going to look and say, well, to get from 1 to 2, in the right column, I'm adding 10. And then to get from the second to the third, I'm adding 10 again, adding 10 again, adding. So each time I'm adding 10. So I'm repeatedly adding 10, which means the coefficient of W is going to have to be 10, because repeated addition is multiplication. What am I repeatedly adding? 10. But if you do that, 1 times 10 does not give you 8. 1 times 10 is 10. So what do I need to do to that 10 to get to 8? The answer is subtract 2. So for each number, each value in the W column, the one on the left, I need to multiply the value times 10 and then subtract 2 to get the value in the right column. So 2 times 10 is 20, minus 2 is 18. 3 times 10 is 30, minus 2 is 28. 4 times 10 is 40, minus 2 is 38, and so on. So my algebraic expression is 10W, like we noticed from what's being repeatedly added, but then I need to subtract 2 to get the value that's given in the right column. This one is a little trickier. You'll notice you're not adding the same amount each time, but you might notice a relationship between what's going on in the left column and the value you're given in the left column to the value you're given in the right column. So it might not be as obvious when I'm looking 1 to 1, because it looks like I'm not adding anything, and then Q would have to just be Q. My expression would just be Q. But when I look at number 2, how do I get from 2 to 4? Well, there's 2 ways. I either add 2 or multiply 2. So let's look here. To get from 3 to 9, I either add 6 or multiply by 3. Now, one of these is going to be a very clear-cut pattern that you can say, oh, I can write an expression for this pattern. Here, you're either adding 12 or multiplying by 4. Here, you're either adding 20 or multiplying by 5. Now, looking at these observations, there doesn't seem to be a real obvious, clear-cut way of doing this. You could say you're adding 4, then 6, then 8. But what seems more obvious is what's going on with the multiplication. I can write an expression to show 2 times 2, or 3 times 3, or 4 times 4, or 5 times 5. We just talked about this not too long ago. And that would be with an exponent. So every time I take a value in Q and multiply it by itself, I get the value in my right column. So I can say my algebraic expression is Q, whatever value I put in this column, squared times itself. Now it's your turn. Pause the video, try this problem in the work section of your WSQ, and then press play again. All right, let's see how you did. You might have noticed that as F increases by 1, my right column is increasing by 6, which tells me there's going to be a 6F, but 1 times 6 is 6, not 8. So what do I need to do with that 6 to get to 8? I need to add 2. Let's see if it works for 2. Because if it doesn't work for all of them, this expression will not work for this table. So what is 2 times 6? It's 12. What is 12 plus 2? 14. 3 times 6 is 18, plus 2 is 20. 4 times 6 is 24, plus 2 is 26. 3 times 6 is 30, plus 2 is 32. So what's the pattern? What are we doing to the numbers in the F column to get the numbers in the right column? We are multiplying them by 6 and then adding 2. Therefore, your algebraic expression is 6 times F plus 2. Try this one. Pause the video, see if you can come up with the algebraic expression that describes this table, then press play. All right, let's see how you did. You might have noticed that every time I go up 1 on the position row, I'm increasing by 5, which means I'm going to have a 5p. 1 times 5 is 5, but I need 7. So what do you need to do to 5 to get to 7? Add 2. Let's see if that works for all of them. 2 times 5 is 10, plus 2 is 12. 3 times 5 is 15, plus 2 is 17. 4 times 5 is 20, plus 2 is 22. 5 times 5 is 25, plus 2 is 27. 6 times 5 is 30, plus 2 is 32. So P would be 5P plus 2. Try this one. Pause the video and see if you can come up with the algebraic expression. All right, let's check your work. You might have noticed that as I'm increasing by 1 on the position row, I'm increasing by 3 in the value of the term. So I am repeatedly adding 3, which means I'm going to have 3p in my expression. But what do you need to do after you multiply p by 3? Then you need to add 4. So each time you're going to take the position number and multiply it by 3, then add 4, which gives you an expression of 3p plus 4. Try this one. Pause the video and see if you can come up with the algebraic expression. All right, let's check your work. Here you might notice every time I add 1 on the position, I'm adding 1/2 or 0.5 or 5/10 to the value of the term. So it's okay to have fractions or decimals as coefficients. So 0.5p or 5/10 p, then what do you need to do after you multiply your position times 5/10? Nothing. You can also think of it as dividing by 2. So there's actually 2 ways you can write this expression. You can write p divided by 2. Actually, there's several ways. You could write 1/2 times p. You can write 5/10 times p. All of those work because they all take your original value and divide it in half. Last one. See if you can come up with the algebraic expression for this table. Okay, let's check your work. You might have noticed there doesn't seem to be an obvious pattern, but if you look at how the position relates to the value of the term in each one of these problems, they have been cubed. So 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. 3 times 3 times 3 is 27, or so on. So the expression you would use for this table is p to the 3rd power, because each of these values gets cubed or raised to the 3rd power to get the term value. Okay, we're done with this video. You can go back and watch any part as many times as you need, or just the parts that you were stuck on, but don't forget to WSQ in your notes.